protocols. Distinguished participants, I welcome everyone participating in all over the world in this World Summit on Science, Tech Management, Sciences 2020 from wherever you are watching the conference, locally and internationally, and from whichever platform you are utilizing. Today marks the long-awaited hour and date set aside to hold the conference as follows. An international lecture delivered at the World Summit on Management Sciences, scheduled on September 21st to 22nd, 2020. Title of the lecture: The Profile of Physicochemical Properties of Spilled Oil, Spilled Crude Oil in Marine Sediments in Niger Delta, Nigeria. The lecture is delivered by Dr. Animia Ajor Words, Ph.D, Registered Engineer, Chemical Petrochemical Engineering Department, Rivers State University, Port Harcourt, Rivers State, Nigeria. Email is as stated. Organizers of the lecture are Science Tech Central Conference, Science Tech Central Incorporation, USA. Brief table of content for the lecture. Brief biography have been sent since. Title of the lecture, abstract, has also been sent. Keywords, background of the research, materials and method, the study area, Niger Delta, Nigeria. On the abstract, I can only take for you now the keywords that controls the abstract, which is physicochemical properties, sample sediment, elemental components, silt and sand, total hydrocarbon content, instrumental analysis. Background of the lecture, of the research. The organizer, Science Tech Central Conference USA, suggested that the title to be delivered at the World Summit on Management Sciences 2020. The lecture emanates from a research work published in the journal EJERS, European Journal of Engineering Research and Sciences, Volume 4, Number 3, March 2019. This is deemed adequate for the conference as a scientific research lecture bordering on the environment, the ecosystem. The research is categorized into the headings: introduction, literature, coincide literature, materials and methods of analysis, presentation of results, discussions and conclusion. These categories are the same as shown in the research paper published in the EJERS 2019. See above. The prompting of the research itself. The entire Niger Delta, Nigeria, is bedeviled with crude oil pollution, consequenting environmental degradations and miserable life to both humans and the animals of the zones. The area is predominantly oil and gas dominated as natural resources, which contribute 90% Nigerian revenue earnings since independence in 1960. The adequate management of these resources has also become a major source of the region's clamoring for reverting back to the old method of governance, old method of regional government arrangement, even at best adopting the geopolitical status of 6 geopolitical zones of Northeast, Northwest, North Central, Southwest, South and Southeast. The reasons being that governance in Nigeria has kept the country in underdevelopment and resources squandering via corruption-driven mechanism rather than purpose-driven for betterment of the nation. This research propels to give the oil and gas Niger Delta areas of Nigeria adequate intellectual backup on the ways to prove to the global community the deleterious evidence of the consequences of the oil prospecting actions in these citizens, which ordinarily can have no proof of the process. What are physicochemical properties? As a very major component of the lecture, the physicochemical properties of the spilled crude oil, multi-component chemical species, are chemical elements identified in the research crucial in causing damages to the environment ecosystem, which brings about low productivity of the agricultural produce annually. Therefore, exploitation and transportation of oil on this area, oily zone, are confronted with strong resistance from the communities. This is because the IOCs international oil companies known for abandonment of the area for decades before the federal government set up the Niger Delta Development Commission, NDDC. The research therefore gives credence to claims of degradative effects on the crude oil contaminated marine, land, and environment. Sole aim of the research. The sole aim of the research lies on the fact that to determine / evaluate the presence of the elemental component species in the 4 sediment sample A, B, C, D by applying the diffusional model principles referred to methods below. Now, coincide literature. The coincide literature here means that the few literatures you have here are literature that explain what happens, what are the various work that have been done in this area. And if you look at figure 1, oil spilled in marine environment showing the main weathering process. This area center for the present research. Then you now have an example of the work done by Peke, that marine sediments can be sensitive indicators for monitoring contamination aquatic environment. The bottom sediments serve as a reservoir for heavy metals and therefore deserve special consideration in the planning and design of aquatic pollution research studies. Heavy metals such as cadmium, mercury, lead, copper, etc. regarded as serious pollutants to the aquatic ecosystem because of the persistent toxicity and ability to be incorporated into food chain. Having taken the few literature that are there, we'll go to the next component of how is the research conducted. The research conducted by taking the materials and methods of the area. I have 3.1 is the study area. The study area is typically Niger Delta, Nigeria. Sediment samples were collected from southern Ajor, Kremo, Ogbuya, Brass, and Nembe local government areas of Bayelsa State. Those 4 local government, these are the zone. You can see the geographical picture of the study area. Now, what is the methods adopted? The main methods adopted for this research is diffusional mathematical models. This is purely chemical petrochemical discussion at this point in time. We look at material species balance within volume, control volume. We take a specific control volume of these samples and now design a column whereby we will incubate them and look at the period of transposition that is taking place. When you design that, that aspect is not here because of time. When you design that and put in the laboratory, you take a sample from these 4 areas and take what they call material species balance within the control volume. Because the control volume is no longer the whole of Southern Niger or Ekromo or whatever. You took the sample and discussed in West. Equation 1, which is the rate of inflow of material into the differential control volume. When you say control volume, is still what we mean by differential control volume, which will be minusing from the rate of outflow of the materials from the differential control volume, dV, then plus the rate of depletion of material due to chemical reaction within the differential control volume. Inside the differential control volume, the interactions of these components with the polluted oil will generate some products that are harmful, deleterious to the human being as we are very hard. Then the right hand side of the equation 1.1 is the rate of accumulation of the species in the differential control volume. Over some time, we will remove the sample and take to the lab for analysis. Then equation 1 can be couched mathematically as follows. As you see there, what you have there is the rate of accumulation in that control volume is given by that mathematical connotation, which is equation 1.2. Equation 1.2 represents the total or net material accumulation of species A. What we mean by species A? Any of those materials, any of those metals in all the directions. The directions are X, Y, and Z direction in the planes. Combining the volumes model, you have equation 1.3. Then equation 1.3 can result by analysis to equation 1.4. Finally, equation 1.4 is the diffusional model for the research, which can be applied analytically for resolving of our models, resolving of our sample in the lab. Now, what do? The research sampling site as the sediment A, sediment B, sediment C, sediment C. And with those ones, having taken them to lab over some time, Analysis will be done on those samples, and these are the results you have. The results and discussion are as follow. The summary of results of this analysis of the sediment samples are given in table 2. In table 2, from the table, the following observations, inferences can be made on the parameters of the sample, and that brings about the physicochemical properties of the sediment A, sediment B, and inside there you can have pH, electrical conductivity, redox potential, temperature, bulk density, particle density, porosity, organic matter, clay, silt, sand, total hydrocarbon content. Then the next one I have zinc. For the set of metals, you have zinc, lead, copper, cadmium, nickel, manganese, iron, and chromium. You can be sure that physical properties are with respect to A, B, C. Presentation, you have pH, electrical conductivity, as I've called in the table. That's what you have there. These are the areas with the parameter that were of interest, that was of interest for us to now talk about what happens in the control volume sample that we analyze. Then the results, further results of the metallic component sample. These are further results with respect to metallic component sample. We have some authorities which you have there. Those results we got will compare with those early authorities, and they are speaking, they are in agreement. So this result is proved to have a very good compliance with existing literatures, with those with Oxford and Spiff 2002, Ajib Oil Company 2006, ECBO and EBOC 1998, Okoye 1991. This can be attributed to the low level of industrial activity in the area. Now, assessment of sandal trap potential of spilled crude oil is in table 2.3. Summary of PSD and total hydrocarbon content of the studied sample. Studied sample is as given as below. The sampling for clay, silt, sand, and total hydrocarbon are given as 1.27, 10, 88%. That's the sand, yes, so it's expected. Then 22.2%. The relation between the concentration of the level of total hydrocarbon content and that amount of silt. That of amount of silt is given, was evaluated using correlation coefficient figure 2. And if you look at figure 2 is actually putting the whole of the result in a better correlational fashion. And our correlation point is 69%, almost 70%. 69.7%, which is a good result. That linear regression of relationship between the levels of the spilled oil and the percentage of silt in the sediment gives us 69.7%, which is 70%. And that proves the fact that the research is highly accepted. The interaction, conclusion, the interaction between some physicochemical properties of sediment in the marine environment has been a concern in developing effective oil spill cleanup activities. The research drives to assess the potential of sediment to trap spilled oil in the Niger Delta area, Nigeria. The study confirms that the trend of the concentration of the total hydrocarbon in the sediment is possibly linked to the percentage of the silt particle, and it is consistent with the literature as stated there, posited by the researchers Bragg and Yang 1995, Lee 2002, Khalifa 2002, Lee again 2002. Then no, it cannot be. No, Sterling 2005. They observe positive relationship between the concentration of the levels of total hydrocarbons and the amount of silt. And the amount of silt is consistent with the literature value as we have earlier mentioned. Researchers have agreed that combinations of oil particles with various names such as clay oil floculations, oil mineral aggregates, and oil suspended sediments, aggregate OSA, is responsible for the trapping of spilled oil with the bottom sediment. That oil can be present in water in two physical forms, dispersed oil droplets and dissolved oil components, and the dispersed oil droplets and dissolved oil components can interact the sediment through one, direct aggregation to form OSA, and two, adsorption on oil incorporation in the sediment phase. These interactions can change the fate and transport of oil by removing oil from aqueous phase. By removing oil by the aqueous phase, which can be an important component of oil spill countermeasure, according to Bandara 2011. Bandara 2011 developed a numerical model to simulate oil sediment interactions and sediment facilitated oil transport in the near shore water. References: you go back to the journals of engineering, European Journal of Engineering Research and Sciences, Volume 4, Number 3, March 2019, and nomenclature online, HTTP. You have it as online. Thank you for listening. Protocols. Distinguished participants, I welcome everyone participating in all over the world in this World Summit on Science, Tech Management, Sciences 2020, from wherever you are watching the conference, locally and internationally, and from whichever platform you are utilizing. Today marks the long-awaited hour and date set aside to hold the conference as follows. An international lecture delivered at the World Summit on Management Sciences, scheduled on September 21st to 22nd, 2020. Title of the lecture: The Profile of Physicochemical Properties of Spilled Oil, Crude Oil, Spilled Crude Oil in Marine Sediments in Niger Delta, Nigeria. The lecture is delivered by Dr. Animia Ajor Words, Ph.D., Registered Engineer, Chemical Petrochemical Engineering Department, Rivers State University, Port Harcourt, Rivers State, Nigeria. Email is as stated. Organizers of the lecture are Science Tech Central Conference, Science Tech Central Incorporation, USA. Brief table of content for the lecture. Brief biography have been sent since. Title of the lecture, abstract, has also been sent. Keywords, background of the research, materials and method, the study area, Niger Delta, Nigeria.